Hello students, good to be back with another chapter today. I am Professor Veena Joshi of Pune University. Today let us do tectonic landforms and structurally controlled drainage. This is a part of process geomorphology. Process geomorphology is a paradigm in geomorphology which started somewhere around 1960 and it is still going on. We have seen different types of processes and landforms which are created by river or created by ocean and created by wind and glacier. Today we are going to see the landforms which are controlled by tectonics, and there are many such features in geomorphology which we call it as tectonic landforms and structurally controlled drainage. Geomorphology is the area of study leading to the understanding of the appreciation of landforms and landscape, and therefore landforms and a process and building material, all three are very important. There are several branches of geomorphology: structural geomorphology, climatic geomorphology, tectonic geomorphology, quantitative geomorphology, and the process geomorphology. There are different types of process geomorphology. When we say tectonic geomorphology and structural geomorphology, they are more or less related. They may not be the same. There are areas on the earth which are structurally weak. They are characterized by joint and the fault, and they influence geomorphology in a very big way. So landform is in total the combination of these factors, that is lithology, structure, climate, tectonics which controls the base level, and ultimately the time. There are many earth features, they owe their form in the large measure to tectonic activity. There are different definitions, and this one is a good one. According to Burbank and Anderson, the unrelenting competition between tectonic processes that tend to build topography and surface processes that tend to tear them down represents the core of tectonic geomorphology. And what is structural landform? They are those landforms which in their appearance reflect and are adjusted to the geological structure of the underlying rocks. So whatever is the feature that it is created, or we go to an area, the drainage pattern or the features which are there, they are adjusted to the underlying geology. So that is what we call it as structurally controlled. So let us focus more on drainage pattern today in this lecture. These are the four main topics that we are going to discuss in the first part, that is the drainage pattern, antecedent drainage, superimposed drainage, and captured drainage. First, let us see what is a drainage pattern. In a normal situation, in a homogeneous rock material, river will flow in the first type called the dendritic drainage, which is tree-like. A main river will be there and there will be different branches join it, like it looks a lot like a tree with branches and sub-branches. This is called as dendritic drainage pattern. This is one such type of drainage which is not controlled by any underlying weakness or geology. The second type, that is trellis pattern. There we see the rivers are going straight line and it is going in kind of a boxes. Then there are some areas where we find the rivers are going perfectly straight line. When the two ridges are going parallel to each other, the river which flows in between does not have any scope but to follow this guided course, and the tributary will come straight from the highland and join it at 90 degree. We have such kind of drainage pattern where, like from a conical hill, they all originate from one highland, radiate uniformly in all the direction. So there are different type of drainage pattern which are controlled by the underlying lithology. Let us take a look at this drainage pattern, that is Alwar district of Rajasthan. This is an aerial photograph. We can have a bird's eye view of the entire drainage system. What we see is there are straight river, there are different joints. So these straight lines are indicating the joint line in geology and geomorphology. The river is following that. So for a distance, river follows a straight line. Again, it goes 90 degree. Again, goes straight line. So this is entirely controlled by the lithology, which is which characterizes this area. In a topo sheet, previously when we did not have any of the satellite images and aerial photograph, we used to identify these features from the topo sheet. And here in the topo sheet, we can see the rivers are all, the main river is going perfectly straight line and the tributaries are joining in 90 degree. Yeah. So this is controlled by structure. Here, this is Girnar Hill. We can see the round rivers here. Because this rock outcrop has controlled the drainage pattern of that area. So again, structure has controlled the drainage pattern. This is a thrust fault. We call it as it's a plunging fault. The river which are flowing over here are also all guided by this. So this is unnatural. Under the normal condition where the underlying rock is homogeneous, we do not see such kind of drainage pattern, but it can be if it has got drainage pattern of this kind. In a topographical map, it looks like this, but a better vision we can get it when we get it from top, the aerial view of it. And here we can completely see how the hill range is going around like this, because it is a plunging fold. So a fold is created because of tectonics only. And all the streams and rivers which are flown in this area, they are all following this. Sometimes we have got bar pattern and parallel pattern. Bar pattern suggests, under the normal condition, once again, when I say under the normal condition, I am referring to a homogeneous rock type. The rivers will have a main river and tributary joints at about 45 to 50 degrees. So if the river is flowing from this end to this end, tributaries also will have orientation coming from there only at an angle of around 45 to 50 degrees. Under the normal circumstance, a tributary will never join from the opposite direction like this. But it can happen if it is controlled by tectonics. Such kind of deferred or unusual junction where a main tributary is joined by, a main river is joined by tributary in an opposite direction. This is called as the bar pattern. Parallel pattern. A main tributary, and I've told it to you already right now that mostly at around 45 degree, the tributary join at around 45 degree angle. In this picture, we see they are all parallel to each other. The tributary is running almost parallel to each other with the main. We call it as the parallel pattern. Once again, this is also formed when it is controlled by structure. So that bar type which I had told you now. A river is, the blue arrow shows the direction of the flow of the river. And look at how the tributaries are joining. At more or less constant angle with say 45 degrees, 45, 46, maybe up to even around 50, but this is how. Suppose tectonic comes. The area has kind of experienced a tectonic tilt. in the opposite direction. The river has started flowing in the opposite direction right now because this was how the river was flowing. Yeah, this is how the river was flowing. So the main river and the tributary was joining happily like this. Now a tectonic has uplifted it like this. The river is going to change its flow of direction, but what will happen to those tributaries? They are all joining at a wrong angle, an angle which is exactly opposite to it. And here is an example of it in the drainage network next to it. This is called as the bar pattern, once again controlled by structure. In reality, we can see such kind of feature, and I would like to make a point here. It doesn't have to be a very huge scale. It can be at the local scale, it can be at the big scale. Identification of them becomes a lot easier nowadays because we have got such satellite images or aerial photographs. The white arrows which are there in this slide all indicate those bar junction where the tributary is actually joining from the wrong angle, from the wrong direction. This is a topographical map of the same area where those tributaries are getting, they are depicted here. The second type is called as antecedent drainage. So let us see antecedent drainage and superimposed drainage. Once again, these are the kind of drainage network or river network which are controlled or influenced by the tectonics. And therefore, they do not follow the normal rule of physics. Now let us see how they are. A river will always flow from a highland to a lowland. It's the gravity, yeah. But what if I find that a river is kind of appears like flowing upward? But it can happen if tectonic is there. In the first picture, what we see is a river is flowing on a plain area, following whatever is the slope that it has. And suddenly a tectonic displacement as well as folding in the next picture. So as the land is rising, the river is undercutting because river can undercut. It can become more powerful or it can aggravate its energy with the rejuvenation. So the base level has rest. So the river has got a lot of energy, it starts undercutting. To an observer like us, how does it look like? The river is actually cutting across the mountain belt, which is, so a river is flowing and we can see the land is rising in between, yeah. As it is rising, the river is simply maintaining its course. So the dead end product is what? A river is cutting across the mountain. So it is possible if and only if the river was originally there and land rising has come up afterwards. I'll play it once again because this is a very interesting feature. So here in this picture what we see is land is rising, the river is simply maintaining its course. Land is rising, river is simply maintaining its course. So river actually did not do anything very extra. It is simply maintaining its course. But a river is actually flowing instead of from highland to the lowland, it is cutting across a mountain. Such kind of rivers. So now it is the actual photograph of that. You see a river is actually cutting a mountain range here. So it happened like that. Such kind of drainage are called as antecedent drainage. That means a drainage which was already in existence and tectonic has come up afterwards and it is cutting across. So it is not in accordance with the geology which is found right now. It doesn't care. It doesn't care about today ka geology or today ka structure because it is kind of adjusting. It was already there. Yeah. So a number of such kind of antecedent drainage can be traced all over. And they are mostly there in the tectonically active areas. These are some of the satellite images where we can see the river is coming straight and debouching into the sea, cutting across the mountains. So they were already in existence, and these mountain belts have come afterwards. So this is called as the antecedent drainage. So again, we can see some pictures over here that cutting across straight. So the very fact that rivers are flowing straight, it is unusual. This is because it is adjusting to the tectonics that came afterwards. These are all the examples of rivers cutting across the mountain. There are several such examples all over. Superimposed and antecedent drainage are actually more or less the same. So, but the difference is very, very slight. Let us see what is the meaning of superimposed drainage. A river is flowing, but here we have to look at the underlying strata and the direction of the river. Right now I am looking at a river which is flowing not in accordance with the geological strata beneath. We have got some 4 or 5 geological strata beneath. One pink color is there, green color, yellow color, they all represent. So the definition of a superimposed drainage is, it is a drainage pattern which is not following the geology which is beneath. Why is it so? That is because in due course of time, here as we see, this was the original topography or original rock strata. Over that deposition and created a flat area over which the river has taken its origin. Later on in due course of time, because it is composed of hard and soft rock, as the erosion is proceeding, some part became, the hard areas is coming up as mountain or ridges, and the softer area is eroded, and the river is still undercutting. If we look at this feature, it also looks like an antecedent river, but the definition is slightly different. In case of antecedent river, a river was already in existence and tectonic came afterwards and it disturbed. But the river is still maintaining and cutting across the mountain. Whereas in case of superimposed drainage, a geological strata of whatever is the origin with already some faulted structure over which came the deposition and creation of another layer. On that the river got originated. As the river is eroding, it starts exposing the underlying rock differentially. Where the rock is hard, it's coming up as mountain range. Where it is soft, it is cutting as valley. Then, so this is the actual. Here, the same thing that I explained to you, here it is happening right now, that it is not in accordant. So this escarpment in a river, once again the river is coming almost straight, once again guided by a fault line, it has cut across and again it is going in a straight line. Such kind of features are called as superimposed drainage. So there are several pictures that I'm just putting it up for you to show. So this river pattern, if we look at it, it is one straight line coming, tributaries are joining in almost straight line. Then again it took a turn, and therefore it is something that we need to remember in geomorphology, that the moment river starts following a straight line, it is if and only if guided by the structure below. And if it starts cutting across the mountain, then it has got to do with a lot of tectonics. So these are the tectonically controlled. Entrenched meander. Entrenched meander means, here we need to, in 1 minute, I will remind you once again what we did in fluvial geomorphology. A floodplain is formed when the river is entering into the lowland or in the plain area. in the second stage. River is already the energy has become very less. That's why it has started winding. The moment river starts meandering in a floodplain, it has already ceased its capacity to undercut. But here when we talk about entrenched meander, we are looking at a meandering with deep undercutting. Yeah? So how can it be possible? It is possible if the river was already formed in a floodplain and later on it started coming up. So the land has come up because of tectonics. The meandering river is still following its course. So you find it in Grand Canyon, you find it in Mandavi Gorge here in Maharashtra itself. So this feature is called as entrenched meander. So this is the result of tectonics once again. Tectonically controlled features, several Gandak river. So if a river has got the energy to cut 500 meters, it won't have meandered in the first place. The very fact that it is meandering so deeply as well as have developed a deep gorge, that suggests tectonics once again, a feature called as rejuvenation. So here we see this feature, this deeply entrenched meanders. This is called as ponding. This is very common in areas where the sediment supply is maximum. Narmada river, it flows through a rift valley. So here also it is straight, a part of Tapi also. So here in Maharashtra, such kind of features are common. In Dudhasagar, the drainage is, following straight line, 90 degrees, straight line, 90 degree. Once again controlled by tectonics or structure as you call it. So a river straight again going 90 degree, going straight again 90 degree, because the joint and a fault line are already there. So river will start following those weak lines. These are all structurally controlled. River capture or stream piracy. Sometimes what happens is rivers are flowing in two different directions, but one of them is flowing faster than the other. So the diagram is self-explanatory. Originally a river was flowing, and this phenomenon is very common on Western Ghats of Maharashtra. A river is flowing and a tributary also is flowing in the opposite direction. It's not a tributary. Another independent river, smaller, but the slope is steeper. So the headward erosion of the river has ultimately caught up with the river, previous river, and the water is diverted into this new, because the slope is steeper. In case of river, slope is the most important thing. So what has happened now is the original river is beheaded. It is chopped off, cut off. So it got diverted and now the whole new system is developed. And many of the plateau river of Maharashtra behave in this manner. Then later on, the river for which the headwater has got chopped off, the water is beheaded, will shrink in size, become smaller in smaller, so many things to happen. This is called as river capture. Why river capture is happening? Many times it is controlled by tectonics once again. If a tectonic uplift happens and the slope becomes more, then whichever is flowing faster will erode faster, and it will catch the previous one. So this is also, a river capture is also another phenomenon. Many of such waterfalls that we find on the Western Ghats, they are the result of this stream piracy. Let us also see, those are in the next 5 minutes or so, let us look very quickly at some tectonic features as well, because till about now what we have seen is the drainage pattern, yeah. So sometimes such kind of features, There is a fault line here and there is an escarpment. Escarpment is, Western Ghat is an escarpment, that a huge wall. And they run straight for several kilometers. And if the strata is tilted, let us see what kind of outcome it gives. Here we see some sketch of a few geomorphic features. One is called as mesa, one is called as butte, cuesta, hogback and flatirons. They are nothing. Originally it was one landmass. Erosion has separated them and carved them into different shapes, but different names have been given. Mesas are formed like how we have got Panchgani tableland. It is the best example of a mesa. Tableland, like a table. They are formed if the strata is horizontal. If the original strata is tilted like this, features like butte also is same as mesa but smaller in size. They are the different stages of plateau erosion and consumption. Cuesta is, it is a kind of a tableland but tilted. Hogback is sharper. And finally flat iron, the last stage. Flat iron means ironing. We iron the clothes. That iron, if we make it stand like that, how does it look like? Like a triangle. So that flat iron, it starts looking like this. All these features are geomorphic features which are controlled by tectonics. Mesas will be formed if the strata is horizontal. So the lateritic tableland of Panchgani and the best example. Cuesta if the layer is tilted in that angle. Hogback if it is tilted in a lot of almost 90 degree. So what I mean to say is, these are all structurally controlled. The same plateau has given rise to different kind of features in the end because of the structure below. Yeah, mesas and butte. The last part. I told you about that entrenched meander. How is it formed? That is the result of new uplift which we call it as rejuvenation. Another feature is the alluvial terrace. Now let us see, a river is flowing very happily on a floodplain, yeah? So it has created large floodplain on either side of it and a tectonic uplift comes. When the tectonic uplift comes, what happens is the base level has gone down, the river has energized. It has got energized, it has got more energy, it will start undercutting now. So it is going to abandon the original floodplain and it is going to create another one. So each time the land is getting uplifted, it is going to abandon the previous one and create a new one, forming different steps which we call it as terraces. Once again, it is structurally controlled. Such terraces are very, very common in tectonically active areas. So, each time the land is getting uplifted, the river is very powerful, let me tell you. Land is uplifted, river is going to cut it. It's going to maintain its course all the time. So, each time it's going to leave behind the previous. And here the flat surfaces that we see on the sides, they are all terraces. They can be paired or they can be unpaired. It depends on how the tectonic uplift is. If the uplift is like this, it will form paired terraces. If the uplift is like this, it will form non-paired, unpaired terraces. Okay? Escarpment is one of them. And the best example of escarpment I gave you is Western Ghats. And on the escarpment, we get to find a number of, so here, Pana range, what we see here, a number of tectonically controlled features. So that straight line which we see, that is the escarpment. So tectonics give rise to formation of escarpment. There are two schools of earth science thoughts. now that the Western Ghats was formed by the tectonic uplift. And there is another school which says that no, it is because of fluvial erosion. At the moment, we don't need to go into it, but such kind of tectonic weakness and displacement can give rise to formation of escarpment. And the pictures that I am showing undoubtedly has shown that all these traits in nature, remember, nothing is geometric in nature. Everything is kind of a merging into each other. Climate from warm, suddenly it doesn't jump into cold. There is a transition. River going straight and suddenly turn to left, right. It does not happen in nature. If it happens, because tectonic can do anything, they don't care. Tectonic doesn't care about anything. And therefore, the resultant topography is totally not in accordance with whatever is our knowledge about other processes. And they are spectacular in nature. They are defying nature. The photos, the pictures that we are seeing now, they are all those hookback and the questars. So, I will summarize in about 5 or 10 sentences what we did today. Like many other climatic zones create different kind of landforms, tectonic also creates different kind of landform. That was the first point. We looked at how river takes different drainage pattern based on the underlying lithology. Yeah? If it is homogeneous, it forms into a tree-like structure called as dendritic. If it is, the joints are going straight and the 90-degree trellis pattern and the parallel pattern and the radial pattern, everything which is away from the dendritic is all controlled by lithology, yeah, or structural characteristics or underlying nature of the rock. We have seen what is antecedent drainage and several examples of that, means it really happens. Then we have, and one more thing here I would like to tell you, they are more visible in the rocky kind of a area because sediments, well, it is not an exception, but such kind of mountain crossing, they are found more in the rocky areas. And then we saw what is superimposed drainage. Then we saw some of the tectonic features, like you can say, you know, I have shown it to you, the entrenched meander or the terraces. They are all the result of the tectonics. And all, then stream piracy or river capture. Then we came to some landforms like mesas or buttes, questars, hookback and flat iron. The same landmass giving into different type of features in the end because of the structure below. So this is what I have to tell you, students. Thank you so much.